So on number one, if we're looking for the period, we have to look and try to highlight one cycle. So if you start there and stop there, then the horizontal distance or the horizontal length of that cycle is the period. So well, we don't see any numbers here, so we look down here, we see a 6. Okay, well that means that's 5, 4, 3, 2, 1, 0, then that means that's, okay, 3. When we look at the amplitude, we're looking at the vertical distance of each cycle. So we go here to here. How wide is that?
1.5.
2. 1 this way, 1 that way, so it's a width of 2. We only need half of that to get the amplitude. And it's easy to find the amplitude when the x-axis runs right through the middle of the graph. So all you got to do is look at that guy. Now, how will we find f of 999? Let's look at each one. Here's 1. F of 1 is 1. 2, f of 2 is -1. F of 3 is 0. F of 4 is 1. F of 5 is -1. F of 6 is 0. So what's f of 999?
It's going to be 3, 0. It's 0. It's going to be on the 3.
Why?
999 is over 3.
Divisible by 3. The pattern you see is that all numbers divisible by 3 are going to be back at 0. So since 999 is divisible by 3, we can predict that it'll be back at 0 by then. All right. Number 2, amplitude. This one goes down a little bit farther from the x-axis than it goes up. It goes down to -2, up to 1. So the width, the total wavelength is 3. Oh yeah, let's do amplitude first. 1.5.
So we're just adding it,
What?
we're just adding 1 and 2.
You have to look at the whole width, which is 3, 1 plus 2, and then cut that in half.
Okay.
That'd be your amplitude. So then the period is going to be right there is the finish of one cycle. Right about there. You've got 6, 5, 4, 3, 2. And how would we find f of 999? Well, let's look at what it is at each integer. At 1, it's pretty close to 1. At 2, it's pretty close to 1. At 3, it's pretty close to 1. It seems to be that way the whole time. Every time we get to an integer, it spikes up to +1 again. So since 999 is an integer, we can assume that that'll be 1. Again. Number 3, we can't, if we start at the y-axis, we never finish a complete cycle before we run off the picture. So we might want to pick a different method. Find the distance between those two, that is one cycle. So then we have to look and see, well, how far is that? We got a scale here, 60, 120, 180, negative 120, negative 180, 360. Amplitude. Go from -2 to +2. There's 1. That means that's a half. 1 1/2, 2. Negative half, -1, -1 1/2, -2. So then your amplitude would be 2. Now what about f of 360? Continue this graph. If that's 120, that's 180, that's 240, that's 300, and 360 is about right there. I know it's going to bottom out at 360 because it bottomed out at 0 and my period is 360. So that means when I get to 360, it's going to bottom out again.
-2.
This one, basically the same. It messes with you a little bit because it says that's 120. Well, that means that's 60. That means that's 180. So if that's 120 here, that's 60, that's negative 180. So then the period is the same, 360. Amplitude. How high is this? 2, 4, 6, 8, 10. So -2, -4, -6, -8. So amplitude, 10. F of 360, since the period is 360 and it peaked out at 0, it's going to peak out again at 360, and that was a height of 10. So if you try to just narrow these down by how far you shifted them from the x-axis, if you just looked at their vertical shift, that -3 right there, I'm not writing on that, there it is, should be, when it's written in its proper form, should be back here. So that means this one was shift down 3. Which of the graphs, if you take and draw a line through the middle of the graph, of all of those graphs on that page, which one has a vertical shift of down 3?
That one.
So if you go through all of these, okay, that one is a +4, so up 4. This one is a -3/2, so down 1.5. This one is a 1/2, so up 0.5. This one is a +50, up 50. This one is a -2.5, down 2.5. Since all of those are different, you should be able to go through those graphs, and then you go to the graph and say, okay, this one is a, if you look at the midline of every, draw a line through the very middle of each of those graphs, and wherever it hits the y-axis would be its vertical shift. If you look at the scale on that y-axis, that could narrow it down. Since all of those are different, that would narrow it down. And you could get it all done just by looking at the vertical shift. Get them all right. Okay, on the retest, I'm going to go ahead and just have this as a fill in the blank. I'm not going to have you write the whole equation out, but they'll be different. So if we want amplitude, and B, and P, and if there's a horizontal, and if there's a vertical, it's supposed to be a K, for vertical. We would need to identify that from the picture. So let's start with the amplitude. What would that be? Symmetric around the x-axis, so whatever that is, 0.3 would be our amplitude. B is the number of cycles between 0 and 2 pi. Well, I don't even see 2 pi. P is how long it takes to complete one cycle. Well, I don't even see a full cycle. I see a half a cycle. So then I can kind of estimate, if I see exactly, I know how long it takes a half to complete, I can estimate how long it'll take one to complete. So it'll complete, if it completes a half by pi, then it'll finish out by 2 pi. So the period would be 2 pi. So then what would be B? B is the number of cycles between 0 and 2 pi. Just finished up right here. 2 pi, have one complete cycle. And you can get that just by using the formula. It's 1, 2 pi over 2 pi, which is 1. So if we We found the B, we found A. Is there a vertical shift? Is the middle of the graph still on the x-axis? Yes. So there's not going to be a vertical shift. So the horizontal shift kind of depends on whether you are going to call this a sine or cosine function. So if you look at what it looks like the most to you, then that kind of determines. And since we're going to do fill in the blank, I'm going to tell you what I want you to use it as. And I'm going to tell you this needs to be a cosine graph. Okay? So we call it y equals amplitude 0.3 cosine A or B, which is 1, x, and we're not going to shift it left or right because that's where cosine goes through. We're just going to shift it up, none. So we can leave it like that.
See, I would have never put that because I would have automatically thought that was wrong. Just because it didn't look like the other equation. Yeah.
It's simple. All it has is an amplitude.
Too much. I think everything.
On number 12, A, 3, B, how long does it take to complete one cycle? Pi. So how many cycles between 0 and 2 pi?
2.
2. B is 2. It's 2 pi. Are we shifting this up or down? Okay. Now we have to decide if we want a horizontal shift or not. What does this look the most like? Sine, cosine? Which one does it look the most like? Cosine naturally starts here.
Okay, then it's cosine.
Sine naturally starts here. Okay. It looks more like cosine, except we're crossing down here as opposed to crossing up here like it normally does. So how do you make it do that? Flip it. So that'd be easy enough. We're just going to make it flip. So when we write the equation, y equals negative amplitude cosine 2x, and then I have no h and no k. So I'd leave it like that. If you wanted to write with the zeros, be minus 0 plus 0. Within the zeros you don't need. If you wanted to write it with zeros in the places of h and k from the center form, you write it like that, but that's better. Okay, number 14, amplitude. I must have. Amplitude is going to be half of 100, which is 50. We'll come back to it. B, how long does it take, or how many cycles between 0 and 2 pi? I'm not even in pi mode down here, so I need to go ahead and find P first. How long does it take to complete one cycle? 16. So P is 16, B is 2 pi over 16, or pi eighths. Pi over 8. Horizontal shift I'll wait on. Vertical shift is going to be what? This middle dotted red line is how far away from the x-axis? 20, 40, 60, and 70. So this went up 70 from the x-axis. That's the vertical shift. Now, when we're looking at horizontal shift, we got to decide, well, does this look most like sine or cosine?
Looks like cosine.
Since if all we did was shift this down, that would be sine. Up 70 puts it right where we want it. So if we just make it a sine graph, then all we got to do is shift it up with no horizontal. So then we write the equation y equals 50 sine.
50.
That's our amplitude.
How is that 50? It's only 120.
And then
Divide by 2.
That's 60.
100 divided by
50 sine b pi over 8. And then x minus h, we don't have a horizontal shift, plus k, we have a 70. Now we can take out, since it's a minus 0, we can take off the parentheses, take off the minus 0, and just do that.
Ooh, I almost got this one right.
And we're backing up to number 13. Amplitude, still the same. Goes 20 to 120, which is a width of 100. Cut it in half, you got 50. B, how long does it take to complete one cycle? I'm sorry, P is how long it takes to complete one cycle. Stop. 24. So B is going to be 2 pi over 24, or pi over 12. Okay, there's B. H, K, what's my vertical shift?
70.
70 again. Now what's my horizontal shift? Kind of depends on if I'm going to call this sine or cosine. If I call it sine and just flip it, that would be the easiest thing to do. So then I have no horizontal shift, and I just need to make sure that I flip when I write it. So sine, y equals negative 50 sine, and I don't have a horizontal shift, but I do have b as pi over 12 times x plus 7. So we do number 15. We go ahead and label stuff, and you might want to label it in pencil. It's probably going to, all your information may change when you get to the next problem. So C, we don't know. A is 6. Angle A is 35. And we want to find, first we want to find side C. So everything is in reference to this angle we know, 35. That means this is opposite side. This is always hypotenuse. This would be adjacent. Do you know the difference? You know how to tell which one's opposite, which one's adjacent?
Jason's next to.
Jason's next to. Opposite is opposite. Hypotenuse is always opposite the right angle. Here's the right angle. There's the hypotenuse. Okay. So C is the hypotenuse. That's what we want to know. We know the opposite side. So when we look at SOHCAHTOA, the one that deals with opposite and hypotenuse is sine. So that's how we know which one we're going to use. So the sine of 35 degrees is equal to opposite, which is 6, over hypotenuse, which is C. Now we need to solve for C, and we're done. Well, here's a couple steps. Times C on both sides, because when the unknown's in the denominator, it makes it a little bit tricky. So C times sine 35 is 6 if I divide by sine 35. Now on both sides. So all I have is C over, or 6 over sine 35. Those cancel. So C equals 6 over sine 35. Put that in your calculator. 6 divided by sine 35. What do you get?
10.46.
Okay, 10.46 would be the length of your hypotenuse. Call it 10.5. If we want B, which is the adjacent side, and let's go ahead and use what we knew in the original, which was the opposite side. Opposite is what we know, adjacent is what we want to know. So opposite and adjacent in SOHCAHTOA is which one? 10. So tangent of 35 is equal to opposite, 6, over adjacent, unknown, b. So I learned from my last that instead of showing multiply by b, divide by tan 35, I just know that I can switch the places of the b and the tan 35, and I'll end up with the same thing. So 6 divided by tan 35 gives you the adjacent side. 8.56. Okay. We're still at 8.6. So that's fine. And the measure of angle B, well, that should be the easiest one of all. If that's 35 and that's 90, that's got to be 55, so that you can get a total of 180 degrees. All right, so number 16. A is 5, B is 12. We need to find the measure of angle B. A is 5, B is 12. We need to find the measure of angle B. How do we do that? Okay, well, let's look at what these two sides are in reference to angle B. This will be opposite, this will be adjacent. So if we set this up, opposite and adjacent is tangent. Tangent of this unknown angle is going to be equal to opposite over adjacent. The inverse tangent of the ratio gives you the angle. The tangent of the angle gives you the ratio. The inverse tangent of the ratio gives you the angle. Second tan, 12 divided by 15. Yeah, 12 divided by 5. 67.4 degrees. Sounds pretty good. All right. Number 17. C is 10. Angle B is 50 degrees. I need to find A. So in reference to the 50-degree angle, this is always hypotenuse. This would be adjacent. So adjacent and hypotenuse is which function? So, so what? Cosine. So the cosine of 50 degrees is equal to opposite or adjacent, which is unknown, over hypotenuse, which is 10. So since our unknown is in the numerator over there, this is going to be a lot easier. All I got to do is multiply by 10 on both sides. So when I type in cosine 10 cosine 50, it will give me the length of that side, 6.426. Call it 6.5.
A, 6.5.
If I want B, that's opposite. Sine.
6.4, 6.42.
Okay. 6.4. So then that's going to be sine. So the sine of 50 degrees is going to be opposite, which is B, over hypotenuse, which is still 10. Multiply by 10. 10 sine 50 will give you the length of that side. 7.7. Okay. And then the measure of angle A, that should be the easiest part. If that's 50, that's got to be 40.